Okay. Welcome, everyone. We are starting to explain how to deploy Zentyal Cloud in your own hardware. And what is important this to you is because this talk will give you money for your business and your privacy. So it's not necessary to provide a cloud solution using only external third party. So you will be able, after this talk, be able to install Zentyal Cloud files in your own architecture. So first of all, I'm going to explain you a little about how Zentyal Cloud architecture in file synchronization works. If you didn't attend yesterday to the Carlos talk, I will explain you a little more about it. Zentyal Cloud file synchronization is based on S3 interface. So basically, you can have a browser, a laptop, with Zentyal desktop client, or you can also have a mobile, or even you can have Zentyal server, and you can synchronize your files to your data center using a S3 interface. S3 interface is an Amazon-defined protocol to to store objects. I explain you later what is object here, and then get it from there. So basically, you can put an object from the browser. It will be stored in your data center and will be retrieved by your Zentyal server. So everything will be stored, every file will be stored in your own premises. This is going to be done using OpenStack. What the heck is OpenStack? Here I'm going to explain you a little about what is OpenStack. OpenStack is just a cloud computing project. What this means? This means that this provides you infrastructure as a service. So you can have everything related with virtualization, a good word that we have. You can virtualize virtual machine, you can virtualize hard disk, you can virtualize networking, and also objects. So everything can be virtualized and managed using this software. This software is open source, and its main goal is to provide private and public clouds. This is a huge hype right now because there's a lot of developers in there. It's more than 300 developers around OpenStack. So it's a huge project, a huge goal, and the main thing is to provide an alternative to the monopoly that right now is Amazon Web Services. So, for instance, we have Rackspace, the origin of the company, the founder of OpenStack, one of them, and now it's an open foundation. What is great? Because it provides you a scenario when you can install several modules. It's very modular, so you can have OpenStack with different things in your mind. For instance, we have compute module that is based on the virtual machines. You can start virtual machines instance, you can terminate one, and you can also have networking a module that connects the virtual machine you have within OpenStack, so you can have different networking without having anything underneath, any hardware underneath. Everything can be virtualized. So you can have a router, you can connect all the virtual machines using VLANs, and everything is virtualized. And we also have another important model that is called storage. There are two things. One is block. It's about virtualizing hard disk drives. So you can have an SCSI hardware underneath, and this can be accessed from any virtual machine within your OpenStack cluster. And we also have the object storage. This is basic on putting something key value store. Is more or less this object has this name that is the key, and you put it in OpenStack cluster, and you get it using a key. And this is very important. That is the name is Swift, and later I will explain you how is this working. Underneath we have the shared servers that we use with OpenStack. So OpenStack provides you a complex situation for authentication. We have a model called Keystone that is very important in order to have this virtual machine can be only owned by this user. We have this project that only have this user and stuff like that. So it's very modular in that way as well. So multi-tenancy is possible and it's very potential. And we also have other services like image and other kind of things that is not related with it here. And the most important thing about OpenStack is that you can use your own hardware, your community hardware. Any computer that you have, any server that you may use, you can use it within OpenStack. Why? Because OpenStack is completely horizontal. The main other goal of OpenStack is having this as with the hardware that you also have. It's not necessary to have a big data center to serve Zentyal Cloud files. You can have it in small PCs, and putting all together, you can have a very nice OpenStack cluster. So now we are explaining in detail what is Swift, the object system, module, and OpenStack. So basically, we have three kinds of nodes. One of them are the storage nodes that we store the data, and they are replicated within it. And we also have the authentication node. Authentication node is responsible for authentication. What I said, this object is possible to access by this user because it's in this project and stuff like that. And we also have the proxy node. The proxy node is the most important here, and is the one who is in charge of connect the clients with the storage and serve the objects. So this proxy node needs to be accessible by the clients. But in our architecture, the authentication node is not needed. Why? Because we are using Zentyal Cloud as the sole client. So this is very important as we explain it now. Swift architecture is nice, but we need some tuning. We said we performed several stress testing with the OpenStack installation, and we see that the authentication module was the bottleneck. So we need to do something, and we say, okay, we have only one client. What we need such an amount of authentication system. We just need a user and a password, and this user and password will be only from Zentyal Cloud. So we have just say, okay, we are going to use a configuration file with one user and one password. And this make great improvement. So it's right. We improve the performance by 2 to 5 times, and it's faster. It's very nice. Well, we also need to make some modifications. We saw that the Swift versioning was it's not really versioning for our point of view. It's just a stock of version. So think about having an object. Well, an object here is a file. So thinking about a file, when you create a new file within Zentyal Cloud Files, you put it an element in the stack. So when you modify this file, it will be loaded a new element. So it will be put over the other one. And delete an object means that you are popping this element from the stack. So if you want to restore a previous version of a file, you will delete forever this element. So it's not possible after a restore operation. You cannot restore your. Oh, sorry. Oh.
No, it's not
okay. It's okay. So. So we have to implement the versioning that we have in Amazon Web Services. The Amazon Web Services versioning is based on normal versioning, and is well, you can have you can use it as you can see in Wikipedia or another source control management tool like Wik, like Geek or Subversion. We can delete an object, but then it can be restored at any point of time. It's called something very cool that Carlos said, is point of time restore. So you can have a history of the file modification, and you can restore it at any point in the time. And this was implemented by Zentyal, well, by Jesus. So we start the workshop, and we are going to explain how our architecture is going to be shown in this workshop. We are going to have a proxy node that is responsible to connect to the clients and the storage nodes, and 2 storage nodes in order to explain how replication and how to have high availability of our architecture. So first of all, we need to have public IP address. As I said, you need to connect Zentyal Cloud to this architecture, so we need to be public or in any way that Zentyal Cloud can access it. Zentyal Cloud web application is stored in the cloud, in the internet, so it's necessary to be accessed. And it needs to be connected to storage nodes using another network, as I'll later explain. So here we have the 4 required steps to install the proxy node. First of all, we are going to install proxy node. Basically, we have to add the OpenStack repository. And the OpenStack repository is available for Ubuntu. We are going to install everything in Ubuntu server. It was our choice. And we are going to install the required things here in Proxy. In the Proxy server, we require to have the Swift and the Swift software and some other dependencies, as we are seeing here. Okay. So now we are installing the keyring. I think it's very fast. But not so fast. Yeah. So basically we have Shift, that is the common package, and then we have Swift Proxy, because this is then the Nodes proxy, and we have also Keystone, and Keystone is responsible for to make the authentication as an authentication client. After it's installed, we make failures, as you can see. We are writing the configuration for Swift. This configuration is mandatory to be done in all nodes, and is saying that we will use a path prefix and a path suffix. This can be modified when you create the architecture, and it will be copied to the other nodes. After doing that, we are creating several things and changing the ownership. When this is done, we have to install the software that we have done. So as you can see, we have cloned our well, it's not installed, so we have to install Git and clone our code. This middleware is responsible to doing the versioning. Installing some dependencies. And then installing as any Python application, right? So, yeah. When this is done, we are configuring the proxy server. There are 2 important things here to be done in the configuration file. One of them is the port that you're using, because after that we are gonna use this port in the responsible to respond to clients. So, and we also have to put it in the configuration file the numbers of workers. As you can see, we select to only listen in localhost. I will explain you later why. And we are putting in our pipeline in the middleware. We are putting our middleware for authentication, as I said, and we also put it the versioning that we have developing in Zentyal Cloud. So here we have the authentication that will be used by storage nodes, by Zentyal Cloud client, and it will be only a user and a password. Oops. Yeah. So after that, finally we have to provide some security. As you can see, we have no secure. There is no security here, so we have to use a SSL layer, and we are using Ngins to do it. So I'm creating our own certificate. So just install it and provide it to you. If you want to put this in production, we need to use a certificate from your for your company. We are saying that these engines needs to access to the Swift proxy and making the SSL layer and then requests this to the client. So here's the configuration of the virtual host as a reverse SSL proxy. We are enable it as any other virtual host, so no hassle here. As you can see, we are listening to the proxy node that we have said that will be in 8080 in localhost. So the open and plain protocol of Swift is not installed, it's just put it in local. And we have here the logs that we are going to use later to see how requests are going. And we have also to modify the maximum body size of the application of the virtual host because we need to use for Zentyal Cloud application to have more than 5 megabytes of data, right? So when we have done this, we have to restore it, and we have the proxy node done. Nothing else is read. So we are now in the storage node. Storage node is the one who has the data. So what the real requirement here is to have it in a private network. Why? Because everything is replicated using rsync. Rsync without any authentication and without any kind of security. There is no cipher data. Everything is plain. So we have to use it in an isolated network. So you have the data and you have to split it in partitions. And every partition will be stored in a storage node. This is the architecture of Swift. And once this is done, we have the replication done, right, using rsync. This is how it works. So how much data you can get in your own cluster? You can have as many nodes as you have, the devices, hard disk drives that you have, and the device space of every device, but you have to divide by the replication factor. So, for instance, if you have 2 terabytes of data in several devices, several nodes, if you want to have at least a level of replication of 2 or even 3, as Swift recommends, you have to divide this number by the replication factor. So if you have 2 and you have 2 terabytes, you will have only 1 terabyte of data. So the steps we are going to follow is install the Swift software as we previously done. Then we prepare the storage devices, and finally we are going to install and configure the rsync replication. So as we did before, we are using the same repository as in the previous video, and we are installing the required dependencies here. So basically we have to install rsync for replication, Swift common applications, and then Swift account, Swift container, and Swift object. These applications will be explained later by Jesus, but it will be based on different things that we have to have in Swift. Is related with it, and we are using here X3, so XFS as file system. Sorry for my spelling, but XFS file system. That is the one which OpenStack recommends for this kind of setup. So as you can see, we have only one device in these storage nodes, and we are formatting this device using the standard tool of this. And when we have done this, we have to formatting the device. And we are gonna mount it in the same place. Look at that mount point because it's very important later in order to have it properly installed. Because if you say that the storage node, in the rsync, you don't say the proper path, you will not have the data the space to replicate data. So we are saying where to mount it and then mount it. And changing ownership, it's very important to change the ownership of this mount, of the mount point to Swift, because the storage nodes and rsync daemon is using Swift user. So there are some key parts that you may have problems. So finally, we are configuring rsync. So we having the local IP address that we are using, and we are having here which rsync configuration file. Don't care too much about the configuration file, because it will be provided to you. If you want to install it as a partner, you will have this configuration file for you. So I don't think there will be a problem. As you can see here, there are several partitions that we have, several things where we can have Swift. So we have accounts, containers, and objects. One we have decided to run it, and we started. So now, stop talking by me, and now it's the time for Jesus to continue. Thank you.
Okay. I promise the following videos are a bit more interesting, or at least the final ones. Well, until now we have the storage node and the proxy node installed, and now we have one thing left to do, which is called the ring, which is, well, it's not the one, but that one. It's an structure defined in Swift that all nodes have to have the ring, and it gives you the ability to know where the data should be, where the real data is going to be, and where the replication are going to be on the physical devices, on the all physical devices. So we have the data, and the ring will say, yeah, that data goes to this physical device, and the replication should be here and here. So, well, so every process, every daemon has the ability to know where the physical data is. So we have to create 3 rings, account, container, and object, because in Swift we have 3 types of data. Account, well, actually the important one is the object, which is the real data, because in this scenario, account and container, we are only gonna have one of those. So a ring, in the end, it's actually just a file, and to create those rings, we have to add the devices we have among all the storage nodes. When we add those devices, we have to define some parameters. The region is not the important one, so well, let's skip it. The zone is the real important one, because it's the logical association of the devices. That means, well, that's important because for the replicas will be placed in different zones. So, for example, well, the logical value to give to the zone to a device will be to have all the device of one server in the same zone. So, well, that's the one. You can do whatever you want, but the normal value for that will be all the devices of one server, the same zone. We also have the weight, which is, well, the weight of the device, which normally the best value will be to give to the device of the size you have available. So if you have a device of 1 terabyte, you put a weight of 1024. So let's see. This video is still running. That's what we have, the proxy node, and below we have now connection to a storage 1 node and a storage 2 node. Kike had not said before, but well, these are virtual machines from Amazon, virtual machines with Ubuntu server from, yes, created from scratch. So we don't have anything. To add the devices to the ring, we are going to create the ring in the proxy node. We need the IP addresses of the storage node. So, well, we are just going to creating some variables. Now we are gonna create the rings. The ring actually, we have to create 3 of them. Account, container, and object, but actually they are more or less, they are the same, actually. When we are creating the ring, we have 3 parameters. The important one actually is that 2. The 2, that means the replicas that we have in the ring. So, well, we are creating 2. Normally, you will want a value about 2 or 3, depending of the total size you have. Well, and now we are just have to add the devices. We add in that string weight, region 1, zone 1, that's the IP address, and the port will change depending of the account object or the container ring. That's the name of the device, and the last value is the weight. Actually, here I don't know the size of the device, so I'm logging to a storage 1 node, and I see 2 gigabytes. This is a demo for demo purposes. Normally, you will have a much bigger value for that. And now we have just to add the same device for the other device, for the storage 2 node, and do the same for the other rings. It's just to do the same. Now we'll see the 3 rings that actually each one has 2 devices. The only thing that changes is the port. And now we have to do the rebalance. The rebalance, what it does is to create really the file and assign the partitions. We have 4096 partitions, and that's the step where it's gonna say this partition goes to this device and the replication goes to that one. And now we see we have the 3 files, and yes, we have to copy to all storage node, which is a pretty straightforward step. It's just to copy the files and change the ownership, and well, that's it. The ring is already important because when you maintain your cluster, when you add more servers, when you add more devices, you have to interact with those files. You have to say you run out of the space, you add a device, you have to go to one server, add the device, like the same way we have done it now, and that's it. You copy the ring, and you don't need to restart the services, and that device is just on the cluster. It's going to be, well, the data is going to be there, and that's it. Oops. So we have now, in theory, deploy our OpenStack Swift. We have the storage node, we have the Proxy node, and we have the ring to put all together. So, well, let's test it. What can possibly go wrong? These are the fun videos, more or less. Well, now we want to, well, this is the first file we create in the first video. That's the configuration of the Swift, and it just has random street for hash purposes, and we are just putting in storage 1 and storage 2. That's the configuration. Well, in the storage node, also in the proxy node, we have only one process 1 daemon. It's the proxy server, and that's okay. In the storage node, we have 3 daemons, one for the account, other for the container, and one for the object. Every daemon has several processes, like object replicator, object adapter, and the same for container replicator, container adapter, and those kind of things. Now we are seeing here those files, those configuration files, which actually the only interesting parameter will be that one, the workers, where we define how many threads we want. We want to adjust that depending on how much cores we have on the machine. There we have started the services in a storage 2 node. Now we are going to storage 1, and we are starting the processor Swift. There we go. So that's where we're working. Now we are in the proxy node, which only has one process, is the proxy server. We only have started one process, the proxy server, and now if we restart engines, it should be working. If we connect from the outside, from a client, the client will connect to engines through HTTPS. Engines will connect to the proxy server through HTTP on localhost, and the proxy server will do whatever he needs to do with the storage nodes. So we are gonna, well, that's the engines log. So we are gonna see, we are gonna leave that like that, the log, and now on my own machine, on localhost, we open a Python interpreter, and we are gonna use Boto. Boto is a common library. It's one of the most used in Python to talk with services of S3. And now we are gonna create, well, we are gonna try to test it, just accessing like if you do with your S3 buckets on Amazon. We are gonna enter in proxy node because we want the credentials, because well, we need to be able to access it. There we go, access ID, the secret key. We need the host. There we go. And that parameter just because. Get all buckets, and we see we have a get request since like it's working. Now we are gonna create a bucket. A bucket is a terminology of S3 in Swift. A bucket is a container, and which in Swift they call an object. In S3 terminology is a key. So fun. So, a bucket in the end is just, let's say, like a folder, and the keys / objects are the files. And one interesting thing, well, one thing that it's different from a folder files is that you can have a bucket inside a bucket. So a bucket is just a flat, it's a flat level. So we have created the bucket, we are listing, there is no keys because, well, we have just created. Now we are gonna create a new key. For example, value new foo. We have seen that we have created the key, but we don't have any requests. That's because we don't have set any data, and there we go. We have there a put bucket / the name of the key. And now, well, if we list, we see the get of the bucket, and we see that the key is it. So, well, in theory, it's working well, and in practice. So we change the data. So now, actually, the purpose for this is to test if the version is working. If we list the versions, now we should have two keys. Two keys with different version ID. We see there is 2. And if we try to get the data, we should see first the value of foobar and the value of new foobar, because is what we have put. We get the content of the first key is new foobar, and the other should be foobar. There we go. And we see the gets has a parameter of the version ID because it's the S3 way. And okay, so now our OpenStack cluster is working, and we can access through a normal client, which in this case is Boto, the client library. So we are gonna now use it with Zentyal Cloud. To do that, that's Zentyal Cloud interface. I'm logging with as an administrator, or try to as administrator of ostest.com company. There we go. This by default we use Amazon Web Services. So now it's using Amazon Web Services, and we have seen that there was a folder called this is Amazon S3, and now I'm trying to get the credentials so we can configure in the admin interface that the backend we have changed and we have deployed an OpenStack, so we want to use it. There are the SSID, the access key. We put a backend name, for example, OS test, and that's the URL, the public URL. And we have a error message that says that the bucket does not exist. So well, we know how to do it with Boto. So very quickly we create the bucket. There we go. So if we save it, now well, just it's working. And one interesting thing is that the folder we have previously no longer is there because the folder was in Amazon. It was in Amazon Web Services. If we put the log of engines, now we can see if we, for example, create a directory. Don't know what. Yeah, we see already the request. The first one is to put that folder, and the other is, well, funny stuff. So, well, it's working, and now we are just gonna upload some file just because we can. There we go. We are uploading those files in a group folder, so after that we are gonna log with another user and we will see those files. Yeah. And that's the last video. Now we are gonna see some real action. With real, I mean what the normal user will do. I'm logging with my user, and now if I go to the staff group, I see the files that the admin user has uploaded. If I try to download one file, we are seeing in the background all the requests that are made. That's one of the files admin user uploaded before. And now we are gonna try to use the desktop clients. Well, no, we are gonna create a folder. Amazing. Now we have two clients, one on Ubuntu and the other on Windows. Now I'm on my Ubuntu machine, and now I log in using the desktop client with my credentials. And there we go. That's the client, and now I want to sync the staff folder because I want the images. And there should be, yeah, there we have the image. Now I think we are going to do the same with the Windows machines. This is the machine of the administrator. He uses a Windows 7. He's logging. He has the client, and now he's gonna synchronize. Well, no, he doesn't understand Spanish. He's changing to English, the application. Yeah. And yeah, he's syncing. We see in the background the request. Well, test. And there we go. We have the images. And now we are gonna try to upload a file from the Ubuntu machine, a big file. Well, big file, I think is 50 megabytes or so. No. the admin is changing the name of the folder from foobar to R. So in the client from Ubuntu, he should see that chain. So it should work. And it's a video. Well, actually, that's taking a bit because, well, the client gets every minute do a listing, so that's probably the max time you have to wait to see the changes is 1 minute, and well, the client changed the name of the folder. Now we are gonna do the test I said is about to upload one file, and meanwhile we are doing that, we are accessing the nodes, storage 1 and storage 2, so we can see how the file is being created. Well, is how the size left of the device is being, well, the use size is being increased. Meanwhile, we are uploading the file. That's one, and both of the devices is gonna be saving things because we have only 2 devices and we have replication of 2. So every file is gonna be saved in the 2 devices. It's no possible other way. So now we are in the client, and now we are gonna just create a dummy file with DD, I think. Yeah. There we go. And well, the icon in the app of the client has changed into syncing, and now the file is being uploaded to the server, and we should see the changes of the df command. There we go. Well, now in the other client we won't see the changes until the file is uploaded, which is what it's. So the file is almost, yeah, there we go. Has been uploaded, and the other client is now downloading the file. There we go. There we have the file. So, well, we have a notification. Let's close it. Close it. There. So, yeah, okay. So it's working. For the end, we are just gonna try one thing, which is something that could happen in a production environment. Would be, for example, if some device crashes, we want that everything keeps working because, well, hard drives crash more than we want, but they do. So we are in the storage 2 node, and we are gonna stop everything. It's a stop. So right now we have only one replica of the data, which is in the storage 1. So if we refresh the web page, it's working because, well, we still have all the data of the storage 1. We still have one replica. So well. And we have just downloaded a file, so despite of have one node, everything of the one node has been stopped, it's still working. So just to finish, a few slides very quickly about monitoring and hardware. Monitoring, well, for monitoring Swift, I would recommend, well, most of the people will recommend to have 2 things. There is no, let's say, a final solution to monitoring a Swift server. So the best way to do it will be to have a normal server monitoring, which could be, for example, Zabbix, and also have one of these 2, Swift Recon or StatsD. More or less they do the same, but they do it in a different way. Swift Recon it's something it's implemented in Swift, and you enable it, and after doing that you could retrieve some stats, some metrics about the state of your Swift cluster. But it's a pull mechanism. You have to write some scripts or do something to retrieve that data and, well, do whatever you want, trigger alerts or feed some other system. The other alternative is StatsD, which is a push mechanism. That means that when you enable StatsD, what Swift do is to send data to a StatsD server, which StatsD server is not something of Swift, is something else. It's a software that creates a UDP server, and it's you can use it for your applications. And a good thing about this is that you can use it from real-time application like Swift, where you don't want to spend too much time sending stats, because, send a package through UDP is really fast. So in the end, Swift for every action is we're gonna send metrics to StatsD, and StatsD is gonna put all together and send it to some other graphical application like Graphite, where you can see everything. And that's actually looks like this. This is a instance of Graphite. In the left we have all the metrics. Well, we have metrics like timers of how much time each request has taken, or all the processes we have like object auditor, object replicator. Those are processes that Swift has, just because he has. Well, object replicator is obviously that his purpose is to replicate objects, and I think it's the one, yeah, we are seeing this. This is a stat of object replicator, and it's the time it takes. For example, we see there a peak. I think that peak was when I stopped the storage to node. So when I restarted, probably that's because that takes a bit more time than usual. So, well, in the end, this solution, StatsD, with a Fabric solution, it will be the best to monitoring a Swift cluster. So, to end, let's take a bit about hardware. These are scenarios. We've put first a small one, let's say 50 user with 25 gigabytes per user. We will use probably one proxy node, a normal CPU, 4 gigabytes of RAM, not too much. And for example, we could use 2 storage nodes with a normal CPU, 4 gigabytes of RAM, and 3 devices of 1 terabyte each. And we will build the ring with 2 replicas. One important thing to take into account is that the total space we have is not the total space we provide to the users, because we are storing all the version of all the files. So, well, we are, for every file, we are saving every history, every change that has been made to that file. For a big deployment, let's say 1,000 user, or with the same storage of 25 gigabytes per user, we will recommend 2 proxy nodes with a CPU with, to be possible, more cores than usual. That's with that we could increase the workers parameters of all the processes to have more threads. 16 gigabytes of RAM because RAM is cheap, and yeah, it is. And we will recommend high availability proxy, because if one node crashes for whatever reason, one proxy node, you could have the other one. We have to remember that the proxy node is the endpoint where the clients will connect. So it's important to, if we have 1,000 users, it's very important to be able to have one app at all the time. And other important thing is that 10 gigabyte network would be really nice to connect the proxy node to the storage nodes. For the storage node, in this case, we have put 6. The CPU is not as important as is for the proxy node, so a normal CPU will work, 16 gigabytes of RAM, and 25 devices of 1 terabyte each. That's because, we have 1,000 users and we have a lot of devices. The ring will have 3 replicas. I put 3 here because, in OpenStack they recommend to use a value 3 for the replicas. And one interesting thing will be, like, we only have one account and one container. We only use one device for those, and the ring of the objects will have all the devices, because that's where the data is, and the objects are the important part. But in the end, the more important thing is that OpenStack, like Kike said, has a completely horizontal architecture, so it's really easy to grow. You can start with one server, you can start with few devices, and when you need more space, you add more devices, you modify the ring, and that's it. I mean, you don't need to start with with, for example, the last cases, with 6 storage node, 2 proxy node is not needed. When you need that kind of hardware, you put it there. So, well, that's the important part. So, let's to sum up. Of other presentation, the important thing is that, well, you are deploying an OpenStack because your data will be yours. So you are hosting your data. You don't trust a third party, and well, your data will be yours. In terms of performance, is as fast as Amazon Web Service, which is really fast. Amazon, well, normally it works very good, so that's because they have right now a really big market because, well, it works. And the deploy of OpenStack and the maintenance is a mechanical procedure, and, well, it's fully supported by us. This is how we do it, so you can also do it by yourself. So, well, I think
We are on time. Yeah.
we are on time, yeah.
We are good.
So, if you have any questions? Or not?
No
Any
question?
Yeah. It's nice when you see the logs of when you are uploading on files and you see the logs of every node and they are doing stuff and you say, oh, it's nice. It's the magic.
The most important thing that we want to emphasize is the data will be yours. So we are not as evil as we may think. We have a cloud, but we are leaving the data on your own.
Okay, if there are questions, we can take a rest till the next one that will be in 5 minutes or so. Okay, so thank you.
Yeah.
And I'll be up.